The Tower of Hanoi. See, there's gonna be poles, right? There's gonna be poles. So in one of the standard settings, what happens is that you are given three poles. This is the source, and let us suppose this is the destination, and this is an intermediary poles, right? So inside the source, right, you are having three disks, let's say, right? One is the longest disk that is placed at the bottom, and then above which there is another disk of intermediary length, and the shortest disk whatever I'm having is placed at the top. This is the setting of disk that is kept into the source. Now all these disks, in whatever manner they are present, right, from shortest to the longest disk, this is the arrangement from top to the bottom. They all needs to be transferred to the destination. Now you can utilize this intermediary pole whatever I'm having, right, to place some of the disk for some amount of time, and then you can shift them back into the destination. That's what you can do. This is an intermediary pole. If required, I can utilize it. If not required, I'm not going to utilize it. Okay. Whatever disk from shortest to the longest length, in whatever manner, in whatever order they are present into the source, right, in that order itself, I have to transfer them accordingly to the destination. Okay. Now, one thing is that, see, if the shortest one is placed above the intermediary or the longest one, right, then in any of the arrangements, I cannot say that the shortest one I am going to keep at the bottom, and above which I'm going to keep the intermediary or the longest disk. Such kind of arrangement is not allowed. Such kind of arrangement is not allowed in whatever relative ordering. If the shortest one is above all the longer disk, it has to be maintained in each and every one of the state. This relative ordering should not be distorted. Correct? So this is what the Tower of Hanoi problem says me. There are given towers with n number of disks. And then what I have to do is that I have to transfer all these disks, maintaining the relative ordering, to the destination, from source to the destination. Correct? Okay then. So how my final structure should be looking like? Can anyone tell? How the final structure would be looking like? Can anyone tell? How the final structure would be looking like? So if the source is there, right, into the destination, I think into the destination, the longest one would be kept at the bottom, above which again, the intermediary longer disk, and above which the shortest disk would be kept. This is it. Okay, this is it. This should be the final arrangement of my disk, correct? This should be the final arrangement of my disk. That's it. Okay. Okay, fine. Can anyone try breaking it into sub problems? What should I do? Okay, what should I do? Suppose that I'm defining a method f. I'm defining a method f, and I say that this method is responsible for the movement of disk. Inside the source, right? It is gonna have four kind of arguments into that. What is at what particular tower, right, the source resides, at what particular tower the destination resides. Let this be named as A, let this be named as B. At what particular tower the temporary one is being indicated as. Okay, so let this be named as C. And how many disks are we dealing with right now? These four arguments would be given to me. Can you try breaking that into the sub problems? The function is destined that all the n number of disks I can try moving. Function is related to movement of disk from source to the destination, keeping temporary one inside the tower C. This is what the indication of the function is looking like. Can anyone tell me how would you break that into sub problems? How can you break that to the sub problem? Okay, what if I try giving you a hint that can I do one thing? Move the top two disk. Whatever top two disk you are having, right? Move them to the intermediary step, to the intermediary tower. Can I do that? Move the top two disk, whatever I'm having, to the intermediary tower. That's it. That's it. That's it, right? I have moved it utilizing the recursive function. This function is to move n number of disks from source to the destination. So what I'm going to do is that I know that if the lowest disk is the longest, that has to be placed first into the destination. So in order to place the longest disk into the destination, right, first, into the bottom of destination, the longest disk should be going first. I should be moving the top two disk, whatever I'm having, from source tower to the intermediary tower. This is my first step. Once this movement is done, what I can do is that I can say, okay, whatever is the longest disk you are having, right? Shift that to the destination. Shift that to the destination. And then you do what? Utilizing another movement function, you bring this disk back to the destination. Can I just try framing something like this? All of you agree with me? All of you agree with me? Tell me that. How to break it into sub problems? I have to say that do one thing. This function is aimed to move the disk, n number of disk, any amount of disk from 1 till n, it can try moving, right? Movement. This function is meant for movement. Movement of what disk? Around what? It's going to move. It's going to move around towers. Okay. So firstly, I can say do one thing. Do one thing. Utilize the same recursive function. Ultimately, it is aimed for moving. So if it can move n, if it can move a larger amount of n disk, right, it can definitely move a smaller amount of disk as well. Okay. So what I can say is that from the source, right, initially all the disks are being destined at source. So from the source, right, to the now destination, initially this function is aimed for destination at B. So what I can say is that right now from the source, n minus the top n minus 1 disk, that's gonna be moved to the temporary tower, right? To the temporary tower. So temporary would be becoming my destination. And I can treat that whatever is my destination into the current function, that would become the temporary one. Correct? That would become the temporary one. So destination becomes the temporary, and I am moving from the source to the temporary tower, first n minus 1 or topmost n minus 1 disk. That's what I'm doing. Once this sub problem has executed fully, then what should I do? That means once the flow of control is back after executing this function, then I know that the upper two towers of intermediary and the shortest length, they are being placed into the intermediary tower. That's done. Then what should I do? Then I should say that, okay, move. Ultimately, we're not moving anything because we don't require to do that. How to indicate the movement? I can just say that. Do one thing, just print a statement. Print a statement. You just say that the nth disk. Let me say that how the convention of the disk is. Let us say that the shortest one is the first disk, the intermediary one is the second disk, and the longest one is the third disk or the nth disk for me, right? So I can just say that nth disk moves from tower source, right? Tower source to tower destination. To tower destination. That's it. I just indicated the movement of my bottommost disk, whatever I'm having, from the source to the destination. That's what I did. And then another thing is left. Another thing is left. These two movements are executed. The shortest one, after shifting the topmost two disk or topmost n minus 1 disk from source to the intermediary one, right? I just shifted the longest disk to the destination, right? Because at the bottom, this should be present to maintain the relative ordering. Then I can say that, okay, whatever n minus 1 disk are already there into my intermediary. Now I would treat that as my source, shift them back to the destination disk. This is what I'm going to do. So again, I have to move, right? Again, I have to employ movement of again n minus 1 disk. What function is dedicated for the movement? F itself. Whatever function I am trying to utilize to shift n disk from source to the destination, similarly, I can just say same function can be utilized to actually shift your remaining n minus 1 disk, whatever is there, into the intermediary tower, right? From there to the destination, right? Because it cannot be residing here. They have to be shifted to the destination in order for the entire shifting to complete. So I can call the function again. I can say right now, whatever disk are present, right, into the temporary tower, right? Into the temporary tower, whatever disk are present, shift them to the respective destination. And let's say that source would be acting as my intermediary. Whatever, apart from the source and destination, okay, whatever tower is being left, you can treat it as the temporary one. You can treat it as temporary one, right? And how many disks are there into the temporary tower? It's gonna be n minus 1 exactly. That's it. Okay, so two function calls would be there. One for first, from source, the topmost n minus 1 disk would be going from the source to the temporary intermediary tower, whatever I'm having, then whatever is the bottommost disk into the source I'm having, I'm going to shift that. I'm going to shift that to the destination, right? And then I'm going to say that, okay, fine. Another task is left. Whatever n minus one disk I am left with into the intermediary, shift them back, move them back to the destination. Rest recursion will handle things on its own. This is how I am to break it into sub problems on an upper level, right? On an upper level, this is how the breaking of the entire problems would be looking like. Correct? Let's try. Let's try writing that into code. Okay. So since we have already written the sub problem, right? We have already written the sub problem. Based on the sub problem definition, let's have a dry run. Let's have a dry run that how overall the movement would be taking place internally, how recursion is going to handle that. Sub problems on an upper level, whatever I have defined for the smaller sub problems as well, right? It's going to behave in the same manner. Further, n minus 1 is going to get broken into n minus 2, n minus 3, and so on. Okay. So let's see that how it's gonna work. So let me write it somewhere how my overall sub problems is how my overall function should be working. So let us suppose my source is A, right? I am writing here. My source is A, my destination is my tower B, and let us suppose tower C is my temporary one. So let this be my destination, let this be my temporary tower. And I am initially shifting, let us suppose n number of disk. Okay, for current case, let us assume that n is equal to 3, right? So okay, fine. Suppose that you are to shift exactly zero number of disk, then what you are going to do in that case? Literally, if I am saying that n equal to that of 0, then I can straight away return from here. No shifting is required in order to shift zero number of disk. So straight away return, nothing is required here, right? Okay, what else I can do? Tell me, what else I can do? If suppose n equal to 1, I can have another base case. If suppose n equal to that of 1, exactly one disk needs to be shifted from the source to the destination, then you can straight away print the statement that, okay, print what? Go ahead to print that disk n moves from source to destination. That's it. Correct. This is what I'm going to straight away print. Even if you don't keep this, it's going to work accordingly, right? It's just that I have to jump to the smaller base case, and here I think the printing here the function calling would be stopped. Okay, so there would be an extra function call. So if you don't want to go to n equal to 0, you can add this particular statement that if n equal to 1, I am just responsible to move a particular single disk from source to the destination. Then what I can do is that I can straight away check the case, I can print the statement, and I can return from here. That's it. Nothing else is required, right? Okay, then if suppose both the case are not matching up currently for the current function call, more than n number of disks are to be shifted, then what I can try is that I can just call the sub problem that from A to C, right? And keeping B as the intermediary or temporary tower, you shift your first n minus 1 disk. Once this function has completely executed, you just try printing that again, whatever is my disk number n, the lowest disk n moves from source to destination, right? I'm going to print the current movement, and afterwards I'm call another function that from whatever into the temporary tower C, right? N minus 1 disk are being kept, shift them back to the destination B, with A being the temporary one for the current function call. And all the n minus 1 that I have kept here temporarily, all those disks needs to be transferred. This is how my overall function call is going to look like. Okay, let's see how this thing is going to work. Right? Okay. So basically, I would be having 3 towers here, right? Basically, I would be having 3 towers. Let me just indicate them by a black. Basically, I would be having 3 towers, and what would happen is that here, there's gonna be 3 disks. The lowest one would be the longest one. Afterwards, it is equal to that of the second longest disk and the shortest disk. These 3 things, right? N equal to 3. and it's gonna be A, B, and C. That's it. Correct? Okay, fine. Tell me, for the first function call, if you are calling for the first function call, then what would happen? Anyone? You have called for the first function call, let's say. You are trying to move from A till B, and you are just saying that C is my temporary disk, right? C is my temporary disk. Then what needs to happen here? C is my temporary disk, and I am trying to move exactly 3 number of disks from A to B. Tell me what would happen from here? Tell me, as per the pseudo code that we have written here, what would happen? Can anyone try telling me that? Both the conditions are false initially, I feel. Right now,
Yes.
for this function call, n is equal to 3, neither equal to 0 nor equal to 1. Then what would happen? Okay, so if we are dealing with n equal to 1, we don't require to keep this. Anyhow, n minus 1 from 3, it would be coming down to 1 first, then it would be touching 0. But I would recommend keep an extra base case of 0, because straight away, if somebody is giving you the case that what if you are trying to deal with the case of n equal to 0, right? 0 number of disk would be moved. Then how would you print the output for that? So an extra case corresponding to that would be sufficient just for the return statement. That's it. So right now, I think the only base case we are having, that is n equal to 1, right? This would be checked, and n equal to 3 greater than that, right? Then what would be happening accordingly? Can anyone tell? Firstly, you are to execute the first sub problem, that from here, right? Do one thing. From here, do one thing. Go to the case of moving from A to C. The source, destination, and temporary. These 3 towers are being indicated, right? So the from the source to the temporary one, right? I'm going to move n minus 1 disk, the topmost n minus 1 disk. So what would happen? What would happen? Inside this function call, you are trying to move from A till C, right? Keeping B as the temporary one, n minus 1 disk from top to the bottom, whatever are there. So it's gonna be top two disk would be moving from A to C, okay, by this particular function call, right? Okay, then, guys, right now this will be at halt, because this is dependent on how the sub problem is executing. Then only I can come back and try executing the function call that is present before. Then what's gonna happen? Can anyone tell? Can anyone tell what would happen here? Corresponding to this function call, I think n equal to that of what? 2. The base case don't hit. You again, inside this function call, you again come to this line and you try to execute this particular function, that you do one thing. You do one thing from A. Whatever is the source here, source remains as it is. Whatever is the intermediary one, right? Right? From here, what would happen? From A till B, the intermediary tower would be becoming the destination. Destination would become the intermediary. And here, from A till B, I would be again trying to shift. I would be again trying to shift the top one disk, whatever I'm having. The top one disk, whatever I'm having. So corresponding to this function call, n equal to that of 1. So whenever this function call would be called, right? Whenever this function called would be made, I think this base case would be true. All of you agree with me? I think this base case would be true. All of you agree with me? Tell me that. All of you agree with me? This base case would be true corresponding to the current function call. Then what should happen? Disk number 1, whatever is the topmost disk, moves from source to the destination. From A to B, disk number 1 gets moved. Then what would happen? Tell me. From A to B, the topmost disk, whatever I'm having, that gets moved, right? So this would be executed. And let me just try erasing the topmost disk, whatever we are having, into my disk, into my tower 1, right? Into my tower 1, whatever is the topmost disk, let me try executing the movement. And this is gonna be shifted to tower number B. Okay, shifted. Then what would happen? After the execution of the print statement that is indicating a movement, we are gonna return straight away. So it would be returning to the previous function call. Then what would happen afterwards? Tell me, all of you, what would happen? You are right now standing at the second function call FACB2. Move top two disk from A till C, keeping B as the intermediary one. So it was dependent on a sub problem, moving the topmost one disk from A till B, keeping C as the intermediary one, right? So this particular sub problem has executed and returned. to the previous function call. Now it's gonna go ahead and try execute its movement part. Inside a function, there are three parts. First, move n-1 nodes, n-1 disk to your intermediary one, then execute the movement of the nth disk, right? So whatever is my nth disk here, the second disk, move that from the source to the destination, move that from A till C. Okay, move that from A till C. Then what's gonna happen? Let me try again erasing this. Let me try again erasing this. So this is now the movement would take place from A till B. Movement will take place from A till B, right? Movement will take place from A till B. So the second longest disk has been moved on to your temporary, what is the, temporary tower C, right? As per the movement. And then this particular disk, this particular function call, right, is gonna go on and try executing its second subproblem. It's gonna go on and try calling for its second subproblem. What is the second subproblem, by the way? What is the second subproblem? It's gonna have, it's gonna say that whatever is its temporary one, B, right? Whatever is its temporary function call, whatever disk we have kept into the temporary tower B, right? Move that back to the destination C. Move that back to the destination C. Okay, moved. Keeping A as my temporary one, right? Keeping A as my temporary one. And I think whatever n-1 exact disk we have kept into the temporary zone B, right? So I'm going to say whatever only disk 1, since the value of n here is 2, n-1, whatever only disk 1 I have kept in my tower B, just move them back to the destination C. This is what I am required to do. Okay. Corresponding to this function call n equal to that of 1, then what would happen? Tell me, all of you. Corresponding to this function call n equal to that of 1, then what would happen? Whenever you call this function, this base case would be hitting, and it's going to say whatever nth disk you are having, right? Whatever nth disk you are having from source, you move it to the destination C, right? You move it to the destination C, and then you return. So firstly, I'm facilitating the movement. So let me just try removing this. Let me try facilitating my movement first. Let me try facilitating my movement, that whatever top disk, the disk number 1 has been kept into my temporary, into the temporary tower B as per the current function call, right? Move that back to the tower C with the help of a new function call. That's what I did, right? Moved it. And then from here, I'm going to return. From here, I'm going to return to the previous function call. Movement is done. This particular, whenever the case n equal to 1 would be hitting, the movement would take place and I would be just returning. So whenever this function call has completed its execution, see, its first subproblem executed, its movement executed, and its second subproblem also executed. All of the things are done, correct? Then you are hitting the end of the function. You are hitting the ending bracket, that is end of the function, right? That means the entire function has been executed and it's going to return automatically back to the previous function call. If there is no return statement at the end, right? If there is no return statement, then automatically the flow of the function call would be back to its parent function. That's how recursion behaves, right? You don't need to explicitly mention return always. If you don't wish to keep return statement, automatically your function flow would be getting back to the parent function call from wherever the current function has been called, right? That's how it behaves. Automatically, if the scope is over, it's going to automatically trace back. That's it. Okay, now tell me what would happen. So you are able to see, right? Whenever this function call, its execution is over, what we are able to see from A to C, right? Keeping B as my intermediary, the top two disk has been shifted. All of you agree with me? All of you agree with me? The top two disk that was kept inside A, right? That has been shifted to the intermediary, to the overall intermediary tower, whatever I am having as C, right? I just treated C as a destination inside the current function call and just said that whatever top two disk inside A you are having, shift them to C. And whenever its execution is done, the purpose is also met. The purpose is also met, right? And when its execution over, we are going to go back to the previous function call so that it can begin its execution again. This function was waiting for the first subproblem to execute. Done. That is done. I have shifted successfully from A till C, right? The first top two towers has been shifted, right? Now what I can do, what this function call can do, can do is that it can go ahead and try execute its movement part. Whatever is nth disk, that is the third disk, move that to the destination. Move that to the destination. So let's try that. Now what would be happening is, just a moment, give me. Move that to the destination. So right now the longest disk, whatever I am having, that would be shifted to the destination B. Right, this part is done. What else? What else would be happening? Tell me someone. After the movement is done for the first function call, then what would be happening? Anyone?
The next function calls. See,
Then the next sub problem would be executing, right? Then the next sub problem. What is the next sub problem, by the way? Can anyone try telling me how, in terms of f, it's gonna look like? In terms of f, how it's gonna look like?
C is the source, B is the destination, and A is the temp.
So what would we will say that whatever, right? From here onwards, the function call would be made, right? Let me write it somewhere else because we don't have enough space. We are just saying that whatever, what is the current, as per the current function call, which one is temporary? C. Into the temporary, right? Whatever disk, whatever n minus one, that is 2 disk you have kept, move that back to the destination, treating A as the intermediary, tower for us. Whatever is not in use, whatever is not the source or destination, just treat that as your intermediary tower. Correct? Because that can be utilized in some intermediary steps. Correct? Okay, then what would happen from here onwards? Right now, you are inside a new function call. Then what would happen here? Tell me someone, what would happen?
Again, check if n equal to 1.
This is a new function call, right? So n is not equal to 1. We are able to see n equal to 2 here. No, not hitting the base case. Then what would happen? It would come to execute its first sub problem. What is it? Shift from its source to the destination. From its source to the intermediary tower, right? Do one thing and treat B into the current function called treat B as the intermediary tower. Shift what? Shift the top n minus 1 disk, whatever you are having, into C. Whatever you are having into the C, into the tower C, top n minus 1, that is top one. Just a moment. Top one disk you are having into your current source, that is C, shift that to the intermediary disk A as the destination and treat that as a destination into the current function call. Okay. So what would be happening here? You are hitting again the base case, right? You are again hitting the base case here. What would happen? It's going to say whatever is the topmost one disk you are having, right? Just move that from C to A. Just move that from C to A. So I'm going to go ahead and say, whatever the topmost disk 1 that has been already kept, just shift that to A, right? Just shift that to A. Why I'm doing so? Because the longer disk is kept at the bottom of C, right? So I need to first bring it to the destination B, then only I can shift my A to the destination B to maintain the relative ordering, correct? That's why we are doing it. So, okay, fine. It has shifted your disk number 1 from C to A, right? From C to A, it has shifted your disk number 1 and it would be returning from here onwards. And then what this function would be doing? Right now, you're again back to the current function call. What it would be doing? It would be going ahead to execute its movement part. Whatever is disk number 2, shift that from source to the destination. That is, shift that from C to B. Whatever is the current source to the destination, there the second disk would be shifted. Then what would happen? Tell me. What would happen? Tell me. So accordingly, your disk number 2 would be shifted from C to B as per the current function call wherever I am standing. And then what would happen? Tell me, anyone. Afterwards, last thing, what would be happening? What would be happening last? You are right now inside this function call. It's going to call for its last sub problem, that whatever into its temporary tower, right? Into its temporary tower, whatever top one disk you have kept, do one thing, shift that back to the destination B and treat C as your intermediary one for the current function call. So right now, again, you would be hitting the base case here. Right now, again, you would be hitting the base case here. And whatever is the topmost one disk is kept into tower number A. That would be shifted to tower number B as the destination. So I think A would be moving on to the top of B, and then it would be returning to the previous function call. Okay, corresponding to the current function call, first sub problem, second sub problem, intermediary movement, all is done. Its scope is over. Its flow is going to automatically go back to the topmost function, which is the main one for me to solve the problem, right? This is the first sub problem. Actually, I wish whatever I wish to solve. It's also left a sub problem, movement, and right a sub problem. Both are done, and its scope would also be over. It's going to automatically trace me back to the main function. It's going to automatically trace me back to the main function. That's it. And at the end, we are able to see entire three towers in the relative ordering, whatever they were originally present, they have been successfully shifted from the source to the destination. Is the flow understandable to everyone? Tell me that. Is the flow clear to everyone? First, tell me that. How the overall movement took place. Should I repeat any part? If you are facing any confusion, then tell me. Should I repeat any part?
No need, sir. For me, it's clear.
All of you? All of you? Only 2, 3 are coming into the classes. Okay, then what should be the expected time complexity? Anyone? What is the expected time complexity? You started off by trying to shift the n disk. Then from here, you are giving rise to two more function call. First shift n-1, topmost n-1 disk to the intermediary tower, right? And from the intermediary tower, you again shift them back to the destination, right? So two function calls are starting off from here, f of n-1, f of n-1. Similarly, it's gonna give more rise to two more function call, f of n-2, then f of n-2. Okay. Every particular function call is going to give rise to two more function calls. So if you are starting off with a single function call, in the next level, there's going to be two more into two function calls. In the next level, there's going to be into two function calls. Okay. So every time the function call with each level is going to be increased by a factor of 2. What would be the maximum depth of the function call? Can anyone tell? Maximum depth of the function call. What that would be?
It should be n minus.
Okay, so f of 1 would be my last function call, right? That I'm making here. So overall, it's going to be n levels. From n till 1, there's going to be n levels. So overall, how many functions we are executing? Tell me that. How many functions you are executing? 2 to the power 0 plus 2 to the power 1 plus 2 square till the time in the last level, there should be 2 to the power n function calls. Okay. Or I can say 2 to the power n minus 1 function calls. If this is my second level, then this is okay, fine. Yeah. There should be 2 to the power n function calls only, not n minus 1. Just let me see. Yeah. Okay. So I can just say this is n levels are there and how I can label them. This is my 0th level. This is my first level. This is my second level. And this is my n minus first level, let's say. So at the end, in this particular function call, if it is my 0th level, then 2 to the power 0 function calls. If this is my first level, 2 to the power 1 function calls. Second level, 2 to the 2 square function calls. So at the end, in the last level, which is labeled as n minus 1, so I can just say that it's going to be 2 to the power n minus 1 function calls at the end. So you add all function calls. You add all function calls, right? You add all function calls. What I'm getting here, basically, what I'm getting here. If I add them, it's going to be GP. It's a GP series. So approximately again, roughly, it's going to be 2 to the power n function calls for me, not more than that. It's going to be 2 to the power n function calls for me, roughly, right? So inside each function, right, what we are doing? Inside each function, what is the thing that we are performing? Can anyone tell? You are checking the condition and printing. Checking the condition, printing, returning. Constant work. Calling functions, printing, calling functions. So overall, I can just say some constant K operation only I'm doing. Calling functions and performing the print operation, checking the condition. That does not take much work apart from some constant K operations, right? So if I am executing exactly to the power n function calls, it's gonna be equal to this amount of unit operation that I do. So overall functions is called overall work I'm doing is 2 to the power into k. If I take that into big O notation, k is a constant. So overall complexity is big O of 2 to the power n. Corresponding to tower of Hanoi as well, the overall function call is going to be 2 to the power n. Okay. How many levels? What should be the space complexity? Can anyone tell? What should be the space complexity? How many levels we are having? N levels. So into the call stack, not more than n function calls. Not more than n function calls at any point of time I would be requiring, not more than that. First f of n would be going, then f of n minus 1, then f of n minus 2 till f of 1. This is the longest chain of function calls that would be there into my call stack. Then f of 1 would return, one function would be popped out. Then f of 2 would be returning, one would be popped out, and so on. This is how it's going to go on, right? So at not more than n function calls are going to be there at any point of time into my call stack. And this is the extra space occupying thing for us. Okay. So overall, it's going to be big O of n space complexity to solve the problem. Okay. Is this problem clear to everyone? First, tell me that. Is this
Yes.
problem clear to everyone? Space complexity, time complexity. Now I leave the coding part up to you. Can you try doing it? I have written entire pseudocode, given entire dry run, how the overall thing should be behaving. Can you try that, everyone? I would upload the code. If you are unable to do it, don't worry on to that part. This is a simple thing to implement. I don't feel there should be much problem right now, but you try that first on your own. Works for everyone? Tell me that. Works for everyone?
Yes, sir. We can try.
Okay. So in the next week, you are bringing me this code part and you are going to paste that on the chat box.
Sure, sir.
Honestly agree? Okay then. Okay. How much is the time, by the way, right now? You wish to do another thing today? You wish to do another thing today? And okay, so what we have taken this week, I think Amir has done for you subset problem, right? We
Yes.
have taken permutations and Tower of Hanoi. Some of the important problems we have already seen. Two things important that are left is merge sort and quick sort. Fine. I will take that in the next week. And in the next Amir's session, I will ask him to take one or two more problems because we need to now pace up for the recursion part. Okay, he will most probably he will start up with the backtracking part, some of the simple problems. Next week, I'm going to introduce you on with that. Please attend his sessions so that you would be able to cover some amount of problems, right? So I'm keeping it till here today. Please go through the video, right? Once more if you wish to. And then next week, firstly, I'm going to cover merge sort and quick sort. And afterwards, we can go ahead. Also, I'm having a demo video on merge sort. If I send that, can you try that on your own first? Tell me that. Would it be possible to try that over the week?
Yes, sir. You can send. We will try.
But it is related to C++. Almost the code is similar because syntax is not going to differ much. Firstly, you can try. Then you let me know whatever is your thought. Then we can take that. But merge sort and quick sort are a must. We are going to take that next week. Okay.
Okay.
And then afterwards, there are a few problems of backtracking that we are going to take. Nqueens is there, rat any maze is there, word search problem, some sort of problem. So I will ask Amit to take word search problem, right? Again, recursively, how to go ahead on grids. He would introduce things. Okay. And then after the standard problems of backtracking are done, we can move on to the standard problems of DP, dynamic programming. Fine. You people are ready, right? To take dynamic programming in the next month.
I think stack given English should be taken first, I believe, because dynamic programming, everything is again very complex things.
Which
That's
one? Stacks
I
and
think
queues.
stack given English is safe, right? I think that can be covered in a month, right?
It would require typically 2 to 3 weeks, not more than that. But fact is, right, if you are just onto the habit of forming sub problems, then that is the thing you actually require inside dynamic programming.
Okay, that comes in the flow. Okay.
Yeah, it comes into the flow. So I wish to cover that, but that's gonna be initially complicated. Now, whatever are your thought process, you can tell me. We can take the things accordingly. Stacks and queues are pretty simple topics. I don't feel much is there to cover there.
Yeah, if that is the case, I think let's
Okay,
quickly
fine. So
wrap
let's
it
do
up.
the till the backtracking part, till some of the standard backtracking questions. Let's first do them, and then we will go on for stacks, queues, and linked list if you people say, and then we will take backtrack dynamic programming. But one thing is that you should not forget to form sub problems. That's the main thing.
Yeah.
Okay, then fine. Okay, then let's keep it till here, and